We are going to continue our exploration of carboxylic acid mechanisms. And one is the reaction with thionyl chloride. Thionyl chloride in the presence of pyridine. And the other is lithium aluminum hydride. Lithium aluminum hydride. And one is just converting an OH into a Cl. That's an important reaction both here and in the next chapter. The next chapter is all about molecules like this. They're called derivatives of carboxylic acid. And this gives us an entree into that chapter. And this is about reduction. Lithium aluminum hydride is always about reduction. Replacing bonds to O with bonds to H. And there's two of them, right? Two new bonds that weren't there before. So we'll get to that when we get to that. Now, normally in the thionyl chloride reaction, when it was alcohols in chapter 10, we did the exact same reaction in chapter 10, people. Mechanism's almost the same, except you do have to be cautious that this is a carboxylic acid. And in chapter 10, this base could not take the H off of an alcohol, which is not a very good acid at all, right? But this is much more acidic than an alcohol. So I want you to do the acid-base step first. That's the only difference, switching the order of steps. That's it. In fact, I won't even two-step it for you because I want it to be very clear. I'm just going to do the acid-base first because you have to do the acid-base first. Lone pair grabs H. And we have a propyl group attached to a carbonyl, attached to an O-. And you also made your pyridinium right here. So I don't know, I'll make that arrow green or something, just so you know. We just made it. It's done for the day. Thionyl chloride, very reactive towards nucleophiles. So this is going to react with the sulfur. And that's the first step in red. The second step is the pi that you broke and made a lone pair. Either that lone pair or one of the other ones comes back and kicks off the first Cl-. Okay? Two steps. Blue second. You got a propyl attached to a carbonyl, attached to an O, attached to a sulfur, still has one chloride, and lost another chloride. There you go. And here we're going to attack, clearly the chlorine ends up attached to the carbonyl that has the propyl. Let's make it attach. Chloride, not normally a good nucleophile. Hits it, pops the pi. After the pi gets popped, lone pair comes back, reestablishes the pi. Elimination. Go towards sulfur. In Chem 242, I let you do this next arrow. I don't want you doing this next arrow in this class. Sorry, in Chem 241. I let you go ahead and do this. I'm going to erase this arrow. I let you do this and say you were done. We're supposed to know that a pi breaks before a sigma. So I don't want you to do that. I want you to do this and say, oh, after you break that pi, lone pair comes back, kicks off Cl. And I want to be very clear. That being said, if you did the blue arrow that I erased and didn't do the purple, because it's in chapter 10, I will accept it. I will be happier if you do it this way. It shows you understand a little more fully than you did in Chem 241. What's going on? Okay? So let's do the reduction now. We got to make, every time you see a H attached to either aluminum or boron, it's the same first step every time, everybody. You got to make hydride. You got to make H with a lone pair and a minus charge. As soon as you see H, aluminum with 3 more H's and a minus, or H, boron with 3 more H's and a minus. You must do this first and do it all by itself. Don't combine it with anything. You've got H minus. H minus. Okay. H minus here has some choices. It can attack the carbonyl, but it's more likely it's going to take a proton, isn't it? Think about it. pKa 5 and the H minus goes towards 35. That's a very strong acid-base reaction. Go from 5 towards 35. You should do that first. And it's like this H minus is kind of, it gets wasted. You get H2, pKa 35, plus propyl, attached to carbonyl, attached to O minus. O minus. Do I need the lone pair? Not really. Not going to use it. There. Need the minus though. So here you need another H minus, and you already showed me how you made H minus. Don't have to show me again. Another H minus. Attacks the carbonyl. You get O minus. But do you get O minus? Do you get O minus? Not really. I forgot the side product here. What is the side product when HAlH3 with a minus loses a hydride? AlH3. I like AlH3. It's got a cool name. It's French. Well, it sounds French. It's alane. Like methane with aluminum, alane. And alane is it's a pretty strong electrophile. Aluminum likes having a 4th bond, apparently. So instead of going towards O minus, go up to alane. Monsieur propyl carboxylate, I introduce you to alane. I don't have a double bond anymore, do I? And we have alane attached. Let's show all the H's in their glory. And the new H here, yay. Make sure that's, that's a carbon right there. We're clearly not done. We've got work to do. I got a bad formal charge on there too. You guys are very polite. You didn't say anything. In review, Orgo 1, aluminum, periodic table, has this above it on the periodic table, Roman numeral 3. It's a group 3 element. It now shares 8 electrons. That's 4 bonds. That's like owning 4 electrons. On the periodic table, it owns 3 electrons. It says so on the periodic table. It has 1 more electron than the periodic table, not 1 less. So what's the formal charge? Negative. Are you positive? No, sorry, messing with you. There you go. Yeah, I don't want to lose a half point. Hey, that's aluminum with a minus again. Didn't we start the day with aluminum with a minus? What did you do when aluminum had minus the first time? Because I want you to do it again. There it is. Let's make H minus. We do need a second one anyway. This would be our third if you're counting. But I need another H minus, and I need Al to end up with two H's because my clue says so. See that? Clue. Side products are clues. All right, so we got F. Oh, and I'm gonna do the next step too. You ready? Can't I kick off the O minus that's with the aluminum now? Look, I got an O minus right here. And clearly it leaves. I mean, you're told it leaves. Please make it leave. New color though, it's not gonna leave before hydride gets off in this thing. And there's your O minus with an aluminum and two H's. Oh yeah. So let's do the funny business like this. There. And there's your PR. And there is your bond to H that was old. And we have a carbonyl again. And now we're into chapter 16. What's he talking about? That's an aldehyde, people. We already did aldehydes reacting with H minus. We did. That was one of our simpler mechanisms, wasn't it? H minus was actually made in the previous step. You're generating O minus and you're almost done. PR. So I knew that was going to happen eventually today. It's not a phenyl. It's a propyl. It's got an O minus. Two new H's. Mission accomplished on the H's there, see that? And finally, HCl gets used once right here. We're not even on step 2 yet. The step 1 took a long time. Step 2, add HCl. You got Cl bonded to H. Yeah. This becoming that. There you go. End of story. Save. See you for our next activity real soon.